So we're gonna, combine what we did yesterday and also in section 1 as well. So if you know the magnitude and the angle of a vector, right? So if these are known, okay, so if the magnitude and the angle of a vector are known, then you can decompose V into its horizontal and vertical components using trigonometry. So remember what we learned in lesson 1. We learned that the horizontal component of the magnitude, right? The horizontal component is the magnitude of the vector times cosine theta. The vertical component is the magnitude times sine theta, okay? And right over here, we found the horizontal and the vertical components. You can actually take these two, right? These two numbers, 36.9 and 24.0, and you can put it in those vector brackets and write them in component form, okay? So that's what we're going to talk about here. If you have the magnitude of the vector and the angle it makes with the horizontal, like for example, a player kicks a ball, at 33 feet per second velocity with an angle of 40 degrees, right? You've got magnitude and direction. Then all you need to do is remember that x is v cosine theta, y is v sine theta. Then you can write it in component form. So the vector v will be written as v cosine theta, v sine theta, or you can also write it in terms of I and j, just like this. So take a look at what we have here. You need to find the component form, right, like this, of the vector v with magnitude 7 and direction angle 70, all right? So we say v is equal to, okay, what's the magnitude? 7 cosine 60, comma, 7 sine 60. That's it. That's it, and you can have the vector in component form, all right? So you know that this is, 7 times root 3 over 2, remember that? Comma, 7 times a half, okay? So when we plug these into our calculator, because most of the time we need them in terms of decimals, what do we get? Can someone help me out there? Yeah, so these should have been switched actually. It's 7, cosine of 60 is 1/2. And sine of 60 is root 3 over 2.
Oh, yeah, I remember that.
Yeah, so it's going to be 3.5. And how much did we say for the other one?
6.1.
6.1. Okay?
That's it?
That's it. Now, if you had to write it in, as a linear combination of I and j, v would be, 3.5i plus 6.1j, okay? Just FYI, okay? All right.
I know we went over this
Uh-huh.
triple check.
Uh-huh.
It's the magnitude when it's got the line.
Yes.
So that's magnitude, and then just the vector is when it's just standalone with the.
Right. Cool.
That was it.
Okay. So here we need to find the direction angle of the vector p equals 5, 9. So why don't we go ahead and draw that vector p equals 5, 9. So 5, 9 means we go 5 in the horizontal direction and 9 in the vertical direction. So that's the vector p, okay? If I want the direction angle, remember what the direction angle is. It's the angle from the horizontal line up to the angle. So that's the angle theta that we need to look for, okay? Now, to find that angle theta, what you do basically is if you drop a vertical, so if you draw the components of them, right? Then is it easy to find that angle theta? Yeah, right? Because the horizontal is 5, the vertical is 9. So theta is inverse tangent of 9 over 5. Okay? Which is equal to 60.9 degrees. Okay? So now, did we even have to draw this? So like if you were to do this again, do you even have to draw it? No. You know that this is the x component, you know that this is the y component, and you know that, the angle across from them is the that relationship is the tangent, so you can easily just find it right there. Okay? All right, so let's put all this together. A quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second. So this is the football at an angle of 40 degrees with the horizontal. So that's the football. Okay, we'll call that vector F for football. What is the resultant speed and the direction of the pass? So let's go back to the beginning. A quarterback running forward at 5 meters per second. That's the quarterback. We'll call that P for the player. Okay? So now we have two vectors happening here. And you see here, the two vectors are sort of drawn like this. But what I want is the resultant speed. The resultant speed is going to be P plus F. Okay? So I need to find P plus F. So let's draw them. No, P is the vector for the player, F for the football. So first what you want to do is draw the vectors and the resultant. Okay? So what's the P vector? The P vector, that's the player. He's going forward at 5 meters per second. So forward at 5 meters per second, like this. Okay? The football is traveling at 25 meters per second at an angle of 40 degrees. So that's going to be 40 degrees with the horizontal, and I want to make that like 5 times as big, so kind of like that. Okay? So that's P. I'm sorry, that's F, which is, 25. And this was P. Okay? Everybody okay with this so far? So remember, we're drawing it this way because we're going to add resultant vectors. We're going to find a resultant vector. So the resultant vector is this. This is F plus P. This is the resultant. What that is so if he is running and he throws the ball at 40 degrees, the ball is going to travel with that velocity. Okay? Okay? All right. So what we're going to do now is we're going to find the resultant. Okay? All right. So here's what we're going to do. We have our two vectors. We have P. Where's P? Let's write P in component form. In what direction is P? In the horizontal direction, correct? So it's all horizontal, 0 vertical. Okay? What about F? F is at an angle. When it's at an angle, you have to do magnitude cosine theta, magnitude sine theta. So because F is at an angle, I say 25 cosine 40, 25 sine 40. Okay, so let's look at where I'm getting the information. Do you see how in the beginning I underlined this in red, right? So that sort of tells you the vector component. It's all forward in the x direction, 5 meters per second, so 5, 0. Then this one is 25 meters per second at an angle of 40. So the vector component of that one will be this number, cosine 40, that number, sine of 40. Okay? Here. Now, if I were to plug these in, how much would that be? 19.15 and 16.07. Okay? Now, my resultant is P plus F. Okay? That's what I do over there. So the addition part is straightforward when you have the components. So once you have the components, the addition part, you add this to this. So that'll be 24.15. And then this to this, 16.07.
So the adding is straightforward just as long as it's in
Component form. Yep. Okay?
Okay.
Yep. You can't add the magnitudes. You can't do, 25 plus 5. Oh, the ball is traveling at 30 meters per second. No. But you can do it this way. So now this is the vector component. This is the vector in component form, the resultant in component form. But this is not the answer that we want. We want the speed and the direction. Okay? So the speed is the magnitude of r. That's what we want now. So can we find magnitude of r? It's the square root of 24.15 squared plus 16.07 squared. It's exactly Pythagorean theorem. So 29.01 meters per second. Okay? The direction now, we just drew it, but we don't know the actual angle for it. The football is thrown at 40 degrees, but because he had the initial velocity when he was running, when the ball starts to travel, it actually travels at a different angle, not the 40. So the direction, it's going to be theta equals inverse tangent of y over x from the resultant. So that's theta equals inverse tangent (16.07) over 24.15, and of course you have to be in degrees. So theta is 33.6 degrees. So these two are the answers, all right? So if we go back here, he was running at 5 meters per second. He threw the ball at 25 meters per second, or meters per second. So if with a radar gun, if you measured the speed of the ball, it would measure 29 meters per second. Even though he threw it at 25, because he was running when he threw it, it's going faster than he is at 29. Okay? And then the angle, do you see how the green is angled slightly lower than this one? Right? So he may have thrown it up like at 40 degrees, but because he was also running forward, the two of them combine, and it's now traveling at a different angle. Okay? Yeah.
Like what angle on that?
So to recap, if you have two different vectors, right? You're going to find the resultant, right? You need to find the resultant. You have to, basically do vector addition. So the most practical way to do it is this. Number one, you write them in component form. You add the components. That's the resultant vector. Now you work with that to find the magnitude and the direction. Okay? So when you do it on the homework, you have to mimic what we did here. All right? Okay.